Graphing quadratic functions in standard form, using two symmetric points to find the vertex. To find the vertex of a parabola in which p, s and q, s are symmetric points. 1. Find the x-coordinate by using the formula x equals p plus q divided by 2. And 2. Find the y-coordinate by evaluating f at the value found in step 1. So in other words, plugging the value you just found for the x into the equation if you know it. So let's start with a quick sketch for reference. Let's label our axis, x and y axis. And let's say I have a parabola that looks like, well, this as a reference. So now if I label a couple points that are symmetrical, meaning they're in the same horizontal plane, there we go. Once again, horizontally, their y value, in other words, are the same. Hence the reason why they're p, s and q, s. So both points have the same y value. Therefore, they're, symmetrical. So symmetric points. Therefore, we can depict that, well, the line down the middle, the green line there shown, would therefore be our line of symmetry in this case. Okay. So in this case, once again, we can define two symmetrical points just by visually seeing them. But what if instead you get two symmetrical values? How do we tell they're symmetrical values, first of all? Well, let's see. It doesn't matter whether you get an equation that is standard quadratic or vertex standard for quadratics, okay? As long as you know they're symmetrical points because p, s and q, s, meaning your y values are the same. Notice the s is representing the y value as being the same y value. But the x values, p and q, are different. See? Same s values. Okay, so therefore we can find the x vertex by using the formula x equals p plus q divided by 2. So this will technically be the vertex formula. So let's try this example and find the x-coordinate of the vertex for the following. Okay, for the first case scenario, 0, 3 and 8, 3. Once again, how do we tell that they're symmetrical points? Well, look at the y value. Both of them are 3. So they both contain a y value of 3. So therefore, the p and the q, or the x values, is 0 and 8. So 0 plus 8 divided by 2, well, 0 plus 8 is 8. 8 divided by 2 gives us 4. So in this case, 4 is our vertex, or x value of the vertex. So let's try plotting them. X and y axis label on our plot. And there is our first coordinate, second coordinate that we were provided, or coordinate point, I should say. And if I put a line down the middle between both of the points, that's technically my x value of the vertex. Somewhere in between there will be my x value of the vertex. That's all I know. Somewhere there, and we call that typically the line of symmetry. Wherever the x value of the vertex is going to be, it's the line of symmetry. So now if I know the equation, I'll plug it into the equation. Unfortunately, in this case, I'm not given an equation. So all I found was my x value of the vertex. Okay. Proceeding on to the next one, next case scenario B. We have negative 4, 2 and 6, 2. Once again, let's notice that the y values are both 2's. So that means it's symmetrical points. So let's label our x and y axis once again. And for this case, I'll graph the points first there. So I can kind of visualize where my middle between both of those points are, right? Kind of count from both points inwards. And you'll find that x equals 1. Or otherwise, we can calculate it using our vertex formula when we have two coordinate points. So x value of the vertex, in this case, negative 4 plus 6 divided by 2, will give us, well, negative 4 plus 6 tells us that it's 2 divided by 2, and 2 divided by 2 is just 1. Or in other words, just like we stated previously, the x value of our vertex, or the line of symmetry, in this case being the same, would be there. So anywhere on that line would be our x value of the vertex. Now we just got to figure out what the y value is. But be aware, sometimes you are not able to find the actual y value if you're not given a y value, or a y equation, I should say. In this case, we do not have equations. So the best we can do is take a guess. Maybe my graph looks like this, Or maybe my graph could look like this. That's one of infinite number of possibilities of what my graph could look like, okay? So once again, those are just two random examples that I provided for you, as it could be something like that. But let me get rid of them, since it may not be necessarily either of those two for this particular case. So we are going to be left just wondering, because in this case all we found was just the line of symmetry or the x value of the vertex. That's it.